So, hello guys, welcome to our next video in the playlist Google Earth Engine for the climate, and we're also going to plot the charts. So today, in today's video, we are going to look at the forecast system data set, which will be forecasting the weather data, including the temperature, precipitation, the humidity, and as well as many more climatic parameters. We'll see 16-day forecast from the present to the future 16 days. So it will be an hourly data set. So let's look at the data set and go dig deep into it. So you can search global forecast system. So yeah, the first one you will get GFS, Global Forecast System. So it's a for 84-hour predicted model. So this one is produced by the National Center for Environmental Prediction, that is the NCEP. So it's also a project of NOAA, the National Oceanic and Atmosphere Administration from USA. So if you can go through the data set, I will go through a quick recap. So the model type is a global data set, so it is available for the entire globe, and the data frequency. So if you can see here, the data frequency is up to 120 hour. It is producing a forecast at 1 hour each, up to 120 hours. It means up to 120 hours the predictions will be for each 1 hour. So after 120 hours you will get a 3 hour prediction temporal resolution after 120 hours forecast intervals. So it is made available at 6 hour temporal resolution, that is it is getting updated daily 4 times a day. So for every 6 hours, so you'll get a new image. So it's not a daily basis, so it's on the hour basis. So coming to its bands and its resolution, so it's quite high, not high, it's low. So it's a 27,000 meters, it means 27 kilometers. So for the spatial resolution, so if you can just go through the bands, it includes all the bands for the atmospheric pressure, temperature, the wind speed and direction, the dew points, precipitation, humidity, the cloud cover, and more. So at a various pressure levels, you will get with its unit what is the description and what is the minimum and maximum value. So you'll also have the units in order to interpret the pixel values. So here you can see the dataset is available from 2015 onwards till the present. So each image will have its forecast to 16 day in the future. So let's start by importing this dataset. So I have an image collection loaded now. So I can rename it as GFS, so which stands for Global Forecast System. So I want to have my region of interest. So let's create a point at near Madkeri. So it's a part of Kudugu region. So today I'm just using a geometry with a single point. So you can rename it as Madikeri. So I have my region of interest, I have my image collection. So now you can, let's start coding. So you can create a variable now. So in today's video we're gonna only forecast the temperature model, and the rest of the precipitation and all I think you can do it by yourself, so if you know how to do it for a single band. So let's create a variable called the temperature forecast. So I have my global GFS data and I want to filter it down. So before filtering it down, let's select my band of interest. So you just go to our data set and go to the bands. So the very first one, temperature at 2 meter above ground. So you will select this. So the temperature is at degree Celsius. So this band will predict what is the future temperature at 2 meter above the ground for every 6 hours up to 16 day in the future. So I have selected my band from the global forecast system dataset. I want to filter it down to my date. So today's date is 5 May. So 2025, 5 to, so let's say uh, I will take the tomorrow's dataset. Tomorrow's date to be excluding because I will show you in the print what kind of image collection is available. So now my filtering is done, so I want to print my temperature forecast and give it a run. So you can see my image collection has loaded and it has 267 elements, so for this particular data set. So if you can just open it and see the features, it has a single band which I have selected, temperature 2 meter above ground. And if you can just open the first image and open the bands and properties, so here you will find the different kind of properties. So you have the creation time, you have a forecast hour, you have a forecast time, and usually the system index time and end and time start. So you just focus on two properties. First one is the forecast time and the creation time and time start. So the image is created at this time, but it is forecasting for the same time. So as you can see, the forecast hour is 0 in here. So in this the time start variable is also looking the same. So if you can just go to the next image, and here you will see the forecast hour is 1 hour. It means this particular image is forecasting the temperature 1 hour in the future. So it is created at the same time. As you can see here, the creation time remains the same, but here you can see the forecast time is different that rather than that of the creation time. So I want to plot this forecast time on my system start date. So in the graph, as you can see, if you go to the documentary UI.chart, so image by series or regions, you go to image by series. Here you will find the X property will usually defaults to the system start date. So I want my system start date to be the forecast time. So how can I change my system start date to forecast time for all the images? So we'll create a function and we will map it over all the images. So now I'm creating a variable called temperature. So for this, I want my image collection, which was the temperature forecast, and I want to map a function to create a function which takes input as an image. So each of the image in my temperature forecast will be taken as an input, and we'll create a variable called forecast time. So ft for short. So I will extract this forecast time from each of the image. So dot get will help you to get the forecast time from each of the image. So dot get is the useful function. So you just copy this forecast time and paste it in here, and I should return each of the image which is set with system time start. So this is the particular property I want to update. So I will set the system startup time start to be my ft, that is my forecast time. So now my function is ready. So let's see if it is worked or not. So I am printing temperature dataset, give it a run. So we have two image collection with the same number of elements, 267 elements. And if you go to the features and open the first image, so here you can see my forecast hour is 1. The creation time as well as the forecast time is different, but this time my forecast time and the time start are same. So it means I can now plot my forecast time in the graph, showing what is the particular temperature in 1 hour future. So the function has worked properly and the mapping is also done properly. So now it's time we go for charting. So I'm creating a variable called chart now. So we have the function ui.chart.image by series. So if you can just go to the documentary of it, we have already used it. So this will create a chart from the set of image collection. So it need a region. So we have already created a region. Remember, we have Madkeri as a region of interest, and we need a reducer. So since it's a single point, there is no such meaning for this reducer. You can use any of the reducer, so it doesn't affect so much. So my scale is 27,000 meters, and X property will be default to my system's time start. So that's it, our chart is ready. Now let's print the chart and see what is the future temperature for the region of Madkeri. So yeah, we have our band mean across the image, and the variables, and the on the y-axis we have the temperature forecast, on the x-axis we have the date and time. So if you can just hover it around, so on the May 5, uh, usually we have highest temperature of 31 degrees Celsius up to. So if you can go to the feature in the May 20, the highest is mean average temperature is 27 degrees Celsius nearly. So as you can see it, where there are peak, it is the peak afternoon is there. So wherever the values have reduced, it's either evening or early morning. So like that you can interpret. So now I want to, let's customize this chart a little bit more. So let's set the options. So the what are all the options I can set is that I want my title, so it's a temperature forecast for Madikeri. Okay, then I want my font size and line width to be modified so that I can know wherever the data are available. So line width I want it to be 1, and font size let it be 2. So give it a run. Yeah, so if you can just open. So here you can see in the initial phases there are a more number of points in here. So it means this predicting that one for every 1 hour it is predicting the temperatures. So as you can see in the future, so the predictions could have more number of hours in between. So for 1 6 hours it has one single image. So I want to customize my chart a little bit more. So I'm just coming back to the script. So let's have my horizontal axis. I want its title to be none, and I want my format to be in year, month, and day. So additionally, I also want to modify my vertical axis. So with the title, let's say we have temperature in degrees Celsius across the y-axis, and I want my ticks to be modified now. So it means what is the interval where the tick should be. So it should be a list. So if you can just open the, it varies from 18 to 34, or still for 30, yeah, 30 to 33. So we'll have 35. So we'll start from 15 and we'll end at 35. So I want it to be regular. So just come here and set it to 5, 10, 15, 20, 25, 30, 35. So you just give a list of values where you want the ticks to be marked. So now if you can give it a run, yeah, it has changed. So it's starting from 18, so I can just start from 15. So there is no need for 5. So however, as you can see, the ticks have changed, and I have my y label temperature x, I have my title of the graph temperature forecast for Madkeri, and I have my legend showing what is the value predicts, and I have my x-axis on the date. So you can just start from 15 and you have your image, quite nice. So if you want to remove this also, so you can rename the band just and you can have this one renamed. So after all this, so let's go to one more charting function. So here we are exploring UI.chart image by series and by region. So this also takes the input as an image collection. So remember, we have regions in the place of region in case of image by series, and here we have series by region. So this is particularly helpful when you are plotting across two regions, and it does require a feature collection which is predicting a feature collection which is representing our two regions. So let's do this. So remember, we have one geometry at a Mercury. So let's I want to have one more geometry at Chennai. So we will plot two lines in here across the two regions but a single band. So you can rename it as Chennai. So remember, it has to be a feature collection. So let's make it a feature and add a property called name for each of the point. And for Chennai also, we need to turn it into a feature, and we should add a property called name. So the property will be Chennai. Okay, so I have my 2 points, one at Madikeri and one at Chennai, and we want to plot the temperature forecast for the next 16 days in the same graph. So this is the particular function which is used for plotting the image collection dot series by region. So here you will find the regions which require a feature collection, uh, or a list of geometry should be required. So here we will use the feature collection. So before proceeding, we want to create a feature collection. So let's create a variable called ROI. So that will be my feature collection, which will take input as my feature collections, and it will have my Mercury and Chennai inside it merged. So that's it. My region of interest is ready. So we are creating one more chart. So this time I will call it by chart region. So we have a function ui.chart.image. So you can always use control plus space in order to autofill your functions. So we have this one, series by image region. So just control plus space in order to autofill. So we need to give the arguments where the temperature is my image collection, and the regions, remember it's a regions, so here it is just a region. So we are giving two regions to plot. So my region is a feature collection having the variable name ROI, and the reducer I want to use is mean, as always, because I want the average one. So the band, so if you have multiple bands in your data collection, so you can specify which band across you want to plot this particular function. So since I have selected only one band, so you can skip this. So if you doesn't specify which of the band you want to plot across the graph, the function will usually defaults to the first band of the image collection, and it will plot that one. So now I can skip the band because I have selected the band already. So the scale will be 27,000 kilometers, and X property will be by default to system start time, and my series property will be named. So the series property is that go to documentary. So it is a property of a feature. So remember, we have created two features, Markeri and Chennai. So it has to label a series in its graph. So we have provided the name property to be used as a label while plotting the chart. So that's it, guys. Just close the brackets, and you can set the options in here. The same options will work. So you can just copy these options and paste it in here. So you will find the line width, point size, everything. So except this line ticks, we can modify later. So now you will print this chart and click on the run. So we'll get two graphs, one with single region, second one with a double region. So this is the latest graph. clearly you can see the temperature forecast. Hot Chennai region, so going up to 36 degrees Celsius in the month of May 18. So 37 degrees Celsius. So as compared to Madikeri in the same region, here you will find 27 degrees Celsius. So for the next 16 days, it's forecasting up to May 21. So I hope guys you have understood how you can do a temperature forecast and know how the temperature varies across the two regions. So here you will find the ticks are varying till 37 or 38. So we can add one more to the ticks and let it be look nice. So yeah, you have the temperature forecast for the region of Madikeri and Chennai, and you have both predicting the temperature for the future. Yeah, so it's a beautiful graph you will get. So you can directly download the PNG, SVG, or CSV. So if you download the CSV, you will get three columns: one along the date, and one with the temperature values for the region of Madikeri, and another column with temperature values for the region of Chennai. So you can download any of the formats directly, and you can modify a little bit more if you are not satisfied with the Earth Engine set options. So I hope guys you have understood how to do a chart of the forecast temperature, so and plot it in the Google Earth Engine. So for any regions you can do, for any number of regions you can do, you just have to have the feature and the geometry, and you need to have a proper data set, and you should know how to manipulate the data set. So that's it for today guys. If you have any kind of queries, you can always post it in the comment section. Thank you for watching.